Hello class and welcome back to Algebra 1B Bootcamp. Today we're going to talk about quadratic terms and shifting. This is something that we spent a lot of time talking about already, so a lot of it might seem like a familiar concept. So the x-intercept, or these are all parts of a graph. If you are going to describe a graph, you have to know its individual parts. Not every single graph will have all of these parts. An x-intercept is the location where the graph crosses the x-axis. So in this case, there's two x-intercepts. The y-intercept is a location where the graph crosses the x-axis or the y-axis. Which is this point right here. Remember, x-intercepts and y-intercepts always have zeros in the point. If it's a y-intercept, it's the point 0, comma, then some number. If it's an x-intercept, then it's a number, then 0. The vertex can be a lot of things depending on what it is, but we a lot of times call it the point where you turn around, the point that's the maximum or the minimum. It's the point where you're really not going up or you're really not going down. So your vertex is the place where the graph changes direction. And then you're talking about vertex, you also have to talk about max and min. So remember, a maximum looks like a mountain, and a minimum looks like a valley. And there are a lot of things dealing with maxes and mins and vertexes. Now, graphs can have more than one max and min. This graph could like continue on and do crazy things. But those are kind of the key things that pretty much a lot of graphs that you see are going to have. Not every graph will have all of these things, but those are pretty common. And a lot of times you also have what's called an axis of symmetry. Also abbreviated AOS, and that's the line that makes your graph symmetrical. So in this case, your axis of symmetry would be x equals -2. Depending on your graph, it's possible to have multiple axes of symmetry. After we talk about parts of a graph, then we can shift the graphs around. And typically, for our purposes, there are two different types of shifting. We have the quadratic, which is the first one. And then we have the exponential, which is the second one. But they do shift the same way. So the negative flips it. Not every single graph will have a negative. The A is stretches or shrinks. A lot of times I'll call it the fat or skinny number. You'll probably remember the fact that I said if it's a fraction, makes it fat. That's the same for both. Just making the graph wider than what the graph usually looks like. The h, notice both of them have an h. The h up here is little, it's stuck with the x. The h right here is in parentheses with the x. Either way, that is your left or right shift. And remember, it's always opposite of the sign. And we'll do an example in a minute. And then your k, notice they both have a k. That's the number on the end. That is your up and down shift. It is extremely helpful to be able to look at a graph and see how it shifts. So for example, in all these situations, you just need to go through and say what each individual part does. So this negative out front flips it. The 9 and the 3 do some shifting. This 3 on the end means you're going up 3. This 9, that's the letter with the, or the number with the x. It's your left or right shift. Since it's plus 9, you actually go backwards 9 or left 9. You will always do the opposite of what it says. Not every single graph has to have every single shift. So this is an exponential because you got the little powers right here, but it still shifts the same way. So if I have x minus 7, this is telling me that I am shifting not backward 7, but forward 7 or right 7. Remember, this big 3 just tells you that you're exponential growth, which we talked about in a previous video. This one is another quadratic, and it just has shifts. Notice no flip over here. So this is positive 8, so you're going left 8. Up and down, and it's down 7. You can also shift lines. You can shift any graph, really. So if I take this, well, this isn't a line, this is a quadratic. My fault. And shift it down 7. So this graph is already shifted. My vertical shift is up 14. Well, if I take up 14 and I take that 14 and take it down 7, so subtract 7, I end up with x plus 1 squared minus 2 minus 7. In turn, the other one is kind of tricky. If y equals x plus 4 minus 14 is shifted left 7, what is the new equation? So technically, this graph is starting at left 4. And I want to take that graph and shift it 7 more to the left. So that means I'm going to shift it 7 more spots that way. 1, 2, 3, 4, 5, 6, 7. So here's my new vertex. I don't know anything else about the parabola right now. So if I start at left 4 and go left 7, the total number that I went left altogether would be negative 11. But remember, this is negative 11. I have to think about the fact that it's a liar. So in here, I put it as positive 11. If you're struggling with this concept, an easy way to do a workaround is to pop it in your graphing calculator. Put one equation in, and then you can count your boxes and get a good picture of what it looks like. Shifting is a very popular concept, and it's also a very popular way to throw in some thinking problems. As you probably recall, back in the day, we did a bunch of checkbox problems. So with these check boxes, you can either click f of x, g of x, or you can click none. Depending on the computer and the program that you're in, you can do there's a lot of different ways to do this exact same thing. So the a value is negative, meaning that the parabola is upside down. F of x is upside down. If I look at g of x, I could graph it. I could use my graphing calculator to graph this. and draw a picture, or I can just remember how it shifts. It's been a while since we've done this, but remember your parabolas always start in the middle, and then you shift it according to the rules. So right 2 and up 7. Right 2. So I'm going to start at the vertex. 1, 2, and up 7. 1, 2, 3, 4, 5, 6, 7. So this value is not negative, so no check mark. The graph is shifted 2 units to the right. So this one is 2 units to the right, and so is this one. So both get checks. 2 units to the left. Well, if they go to the right, they can't go to the left. 6 units up. Well, let's see. This one is 7 units up. This one is also 7 units up. So neither and neither. The vertex is at 2, 7. 2, 7. 2, 7. So that's both of them. The axis of symmetry is x equals 2. Sorry, I have my parabola in the wrong spot. It should be right here. But I don't think it's messed up any of my problems, because I did realize that it shifted left too. Okay, anyway, continue. Axis of symmetry for both is at x equals 2. Parabola has 2 x-intercepts. Well, that's not true. Oops. It's not true for this one, because it doesn't even cross the x-axis. For this one, since it's upside down, it crosses the x-axis in 2 spots. The range is 6 to infinity. That means that your range starts at 6 and gets bigger forever. So like 6, 7, 8, 9, 10, blah, 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 are all in the range, meaning all the y values. And in this case, that's not true, because the vertex is 7 and it goes down. In this case, it starts at 6 and goes to infinity. Well, that's not true for either one. And the domain is all real numbers. We know parabolas always have domains of all real numbers. And this last question is kind of a tricky one, and this is definitely one that I would use my graphing calculator for. So we want to select all that apply of this list of equations that match that graph. So do note that this graph goes up by 2. So this is the 3, 2. And so the graph that we graph in our graphing calculator is going to look a little different than this one. But we should probably be able to figure it out. See if I can get all these in the same window. There we go. So go to your y equals, clear out anything that's in there. This is one of those times when you really have to graph them one at a time to see what it looks like. So I'm looking for x-intercepts at 2 and 4. And I'm looking for vertexes that are at 3, 2. If I've got that, then I'm probably good. 3, 2. So that one. And go back to your y equals. Now notice between this one and this one, that one has a -2 and this one has nothing. But they still are both in kind of a shifting form, so I would say the second one isn't going to work. Now compare this one and this one, C and F. They're kind of the same. So let's go back to my y equals. Parentheses, x minus 2, close parenthesis, and x minus 4, close parenthesis, and we'll see what happens. So let's see, 2, 4, and then this one right here is the 0.23. That one's cool. That one is good. Since these two are almost exactly the same,